particle x travels in a straight line. Velocity is this. Acceleration of x is 0 at t equals p and q. P is smaller, so acceleration equals 0. Acceleration is v prime or dA dt, so we differentiate v with respect to t. After we differentiate, we bring the power down. 3 times minus 0.1, the new power is 2, you have minus 0.3 t squared, and so on. So we differentiate, we get this. We can divide both sides by minus 0.3, and then we factorize, and then we have 2 and 10. P is the smaller one, so P must be 2, Q must be 10. It is given that the velocity of x is 0 at 14. Find the velocities of x at P and Q, and hence sketch. Okay, so this is the velocity function before. When the time is P, we know the P is 2, we replace the time with 2, we have 0. And when the time is Q, we know the Q is 10, so at Q the velocity is 25.6. Now previously it's given that the velocity is 0. Okay, here it's given. So when the time is 2, the velocity is 0 here, and when the time is 14, the velocity is also 0. So we have two x-intercepts, and we know that the acceleration here, the acceleration is 0 when the time is 2 and 10. So that means when the time is 2 and 10, we have stationary points, because acceleration means v prime means the gradient is 0, so we have a minimum maximum here. Okay, so since we know this is a minimum, this must be maximum, so this is the graph. Alright, next find the distance traveled between 0 and 15. So between 0 and 15 means we need this area and this area and this area. So for the area above the x-axis, from the integration we will get something positive, so we just integrate from 0 to 14. But when we integrate from 14 to 15, from the integration we will get something negative. So to find the distance, we need to use the positive value of the integration minus this negative value of the integration. Okay, so that's why we're doing 0 to 14 minus 14 to 15. Okay, because again from here we're gonna get something negative, from here we're gonna get something positive. The total distance is whatever positive from here plus it's gotta be something positive also. Okay, so the integral of v is s, so we are finding s of 14, so we plug in 14, plug in 0, subtract, plug in 15, plug in 14, subtract. So we have s14 minus minus, so that's plus s14, that's why we have 2 s of 14 minus s of 0 minus s of 15. So now we need to find s of 14, 0, 15. Previously we have the v. To find the s, we integrate. So the integral is rewrite the coefficient, the new power is 4 divided by 4. Rewrite the coefficient, the new power is 3 divided by 3. This is actually 2 to the power of 1. Rewrite coefficient, new power is 2 divided by 2. This is actually 2 to the power of 0. Rewrite the coefficient, new power is 1 divided by 1. Okay, so that's how we integrate. We can simplify. 0.1 divided by 4, we get this. 1.8 divided by 3, we get 0.6. 6 divided by 2 is 3. And we plug in 14 and 0 and 15. Use a calculator, we get this and this and this after you plug in. So now we're ready. We know that the s of 14 is this guy, we plug in. We know that the s of 0 is 0, and we know that the s of 15 is this guy. Use a calculator. The final answer in 3SF is 184 meters. Alright, I'll see you again next time.